Welcome back to Compost, a resource for Western agriculture. During the first part of the program, we discussed the potential value of composts. In this part, we will look more closely at specific compost products and how they should be used. I want to remind you that we want you to send in your questions for our expert panel to address. Again, the phone number is 1-800-390-7551, and the fax number is 1-800-803-5998. Again, you can also send us a message via email at cerwa@uidaho.edu. Okay, once a grower decides to use compost, the next task is to determine what compost product to use. It comes as a surprise to many people that all composts are not the same. Compost products do share certain characteristics that define them as compost. For example, they all are products of decomposition, they are soil-like in consistency, and are rich in organic matter and microorganisms, and they serve to improve soils and plants. But beyond these basic traits, compost products differ greatly. Different ingredients, processing, management, all determine the makeup and the performance of compost. Compost that is made primarily from mixed yard trimmings tends to have high levels of organic matter with lower nutrient concentrations and a fibrous or woody texture. These composts are excellent for uses such as mulching, erosion control, or for general soil improvement. In contrast, manure-based composts tend to contain more available nutrients, plus they have a finer and more consistent texture. However, manure composts can be high in salts. Poultry manure compost is a particularly good source of available nitrogen. Manure composts are well suited to agricultural applications which depend on compost for fertility. While there are good uses for all well-made compost products, compost perform best when their qualities match the application. In the next video, farm compost users and advisors describe the compost qualities that they find most important.
I think they need to think about why they're using compost, and if it's for nutritive value, they need to look for a compost that's going to give them that. There's some composts now that are in pelletized forms that you can get with added nutrients in it. There's if you're adding compost just to improve the organic structure in the soil, then you need to look for a different kind of compost. So it really depends on the soil type you have and what you're looking to improve.
The qualities of compost important to users depend on their uses for the compost and their farming philosophy.
Good quality compost in my mind would be one that's fairly uniform. It should be fairly easy to spread. It should be also material that doesn't have a lot of weed seeds in, because I know that'd be a concern by a lot of growers. It should have a nutrient value that I'd expect some return out of it.
The qualities that I look for in a good compost are consistency in the compost that I'm getting. I don't like to get clumps and flakes together. I want to get all the same finished consistency in the product so that I can deal with it as a consistent product. I look at fertility levels. I look at pHs and moisture levels. And primarily those are the four categories that I look for when I'm out looking for compost.
We want a highly aerobic product, finished, so that when you pick it up and smell it, it smells like fresh garden soil. There's no ammonia smell. There's no sour off odors in it or anything else. It's very important that we get a good product, and so we're quite particular about it.
I guess I'm going to want to see evidence that it's composted sufficiently so it's free of diseases. And I'm going to want to see, I want it to smell, have a neutral smell to it, an earthy smell rather than a manure-y smell or a garbage smell. I want it to smell like earth on a warm spring day. I want it to feel like humus, like have a fine crumb structure, and I want it to be relatively free of big chunks of wood and so forth that sometimes commercial compost is full of. And I want to have evidence that it's going to be rich in humus, which will increase the cation exchange capacity of the soil. and I want to look at the ingredients list to see that it's made with sufficiently rich materials so that it'll undergo mineralization and release a lot of nutrients. And I guess I'm very concerned about the cost. Commercial compost that I've looked at before and have had growers purchase before has been rather costly. You could say that compost is priceless in that it provides such a valuable input to the soil. But when you have to add up what it's going to take to produce a paying crop, and compost doesn't necessarily directly contribute to getting that particular crop off, then sometimes it's quite costly.
Compost users have a variety of methods for evaluating compost. These range from simply feeling and smelling the product to the use of sophisticated laboratory tests. Many compost producers and users rely on laboratories to provide important information about the chemical, physical, and biological qualities of compost. To help tell us more about laboratory evaluation of composts, we're joined now from Colorado by Robert Miller. Bob is an associate professor affiliated with Colorado State University and is the coordinator of the North American Proficiency Testing Program for Analytical Laboratories. Bob is also involved in an effort to develop laboratory testing standards for compost materials. We're glad to have you with us, Bob.
Well, good morning.
Good morning. Tell us a little bit about the process of testing compost. Are there lab tests and laboratories specifically set up for compost, or if not, what tests are typically used?
Well, generally, this is kind of a new area for laboratories. There's not a lot of laboratories that are in the testing field that do compost analysis. I myself am familiar with probably about 30 labs across the U.S. which would, quote, routinely run compost. And routinely is the operative word because it could be, I'm talking laboratories that run maybe 10 to 20 composts a minimum per week.
Okay. Are there specific physical and chemical analyses that a compost user or producer should request from a lab?
Well, generally speaking, I would say it really depends on what his or her experience is with compost. Generally, what we do in our proficiency program on it, we go for the basics in terms of quantitative analysis, and that being total nitrogen, total carbon, salt content, heavy metals. Now, there are other people who have particulars that they're interested in being CEC, humic matter content, and some microbial fractions. Currently, our proficiency program emphasizes then on the metals and on the nitrogen and carbon compounds in the material.
Okay, we're interested also to know, are all the testing labs the same, or should a producer or a user shop around?
Well, I can't say that they're all the same because for the most part, again, this is an industry that's just evolving. I mean, hasn't been a lot of compost analysis going on in the past, and the market itself has grown so much, I'd say, in the last 10 years that these labs are still coming online. As per date, we do not have official methods that we have designated for the analysis of compost, and generally we have borrowed methods from other areas, be it soil testing, water testing, and plant analysis. But generally speaking, when I look at a compost material, I like to see the total organic carbon content, total nitrogen content. From that I can calculate a C to N ratio. Based on feedstocks, I like to see what the EC content is of the material, and specifically looking at how much chloride it may have. In terms of metals, generally speaking, some in certain areas, heavy metals are a key topic, and if you're dealing with a feed source that's going into the compost that does have a potential for heavy metals, you want to have these tested.
Okay, Bob, I understand that you have some literature available that deals with compost analysis. Would you describe that a little bit for us?
Well, I operate what I said is the North American Proficiency Testing Program, and this program does soil and plant analysis for labs across North America. We have 170 labs in that program. A year ago, we initiated a check sample just as a means of evaluating what labs' needs were of a compost material we sent out to 170 labs, of which 65 gave us results back on. And there's been such a strong interest in this, we've kicked off a program beginning in 1999 now called the Compost and Analysis Compost Analysis Proficiency Program. And we expect to have 30 to 40 labs across the U.S. and Canada enrolled in that program. Labs will be provided check samples 3 times during the year, of which we'll have them provide the analysis, and then we will tell them how well they've done. Now, the Compost Council will be coming out with a methods manual for these labs, and we will, as soon as that is available, we will be adding additional methods to the program. But for $19.99, we will limit this strictly to standard elemental analysis of the compost materials. When we have microbiological tests online, we'll add those too as well. And generally speaking, based on that sample we sent out last year, we were quite impressed that total organic carbon, total nitrogen, salt content, labs precisions was very good. There was very little bias noted in the laboratories. On the other hand, when it comes to heavy metals, such as arsenic, lead, selenium, cadmium, these things, we noticed that there was quite a bit of variability and what we call room for improvement in the industry.
Great. Well, thank you for joining us today, Bob, and for providing us insight into laboratory evaluation of compost products.
Thanks.
One of the important attributes that we've discussed earlier about compost is the ability of compost to help suppress plant disease. And I'd like to ask Marcy Grebus whether there are methods available to determine in advance if a particular compost product will suppress diseases. Marcy?
Well, Eric, yes, we have a number of laboratory and greenhouse assays or quick tests in order to look at whether or not a particular compost may be disease suppressive. One of the aspects that you have to consider in disease suppression is maturity, and it's a fairly controversial term or topic, but I look at it as basically, is the compost sufficiently decomposed and stabilized to be not harmful and beneficial to plant growth? And we have a number of, one of the reasons that we need to look at maturity is that when you consider the microorganism mechanisms that I described earlier, beyond competition, the other ones, the hyperparasitism and antibiosis, those mechanisms are only used by microorganisms when they're in basically a state of starvation. And in an immature compost, there's too many free nutrients available in order to allow those microorganisms to be actively producing the compounds necessary in disease control. So sufficient maturity is necessary, and we do a quick test in the laboratory using cress seeds. Any sort of fast germinating seed that's sensitive can be used, and you can either germinate the seed in a small amount of compost or a water extract made from the compost, and then compare that to plain water or a known well-composted material, and do maybe a 24-hour germination test. Then you can also do small plant tests looking at whether or not a compost is disease suppressive by doing pot tests where you take a known soil or mixture that is pathogen infested and the known crop seeds, but you want fast-growing seeds like radishes or say tomato seeds or ryegrass. Then you plant those into a material amended with compost, and you do maybe say 5, 10, 20 pot replications, let those grow a certain amount of time, and then rate them for disease. But the critical part in this type of study is to have a control material used and set up equivalent pots that you know are pathogen-free, and then compare the difference. And with composts, as we've talked, being are not necessarily consistent, or there being a lot of inconsistency, you may want to work with several different batches.
Okay, great. Well, thank you. You mentioned maturity of compost, and that certainly is an important consideration. Maturity refers to how actively compost is continuing to decompose. It can be a critical factor in the appropriate use of compost. For example, an unfinished compost in certain applications, such as in potting mixes, may be actually harmful to plants. To help us better understand the relationship between compost maturity and use, we've called on Will Brinton of the Woods End Research Laboratory in Mount Vernon, Maine. Will is a highly respected scientist and consultant in the compost industry, and his organization conducts compost analysis and research, and has also developed several commercial methods to evaluate compost quality. Will, we've heard a lot about compost maturity. Can you tell us just exactly what maturity is, what it means?
Yeah. That's always a very interesting question, and I'm sure we all realize that people often define maturity based on their own background. For example, chemists have a view and microbiologists have another view. I've even heard reference to maturity versus stability as though they are very different. But I would say for most purposes, those refer to the same thing, and that goes for other ways of defining maturity. So what I'm saying is we should recognize this common element, and that is humification. And to define humification, I'd say it's essential to understanding maturity because breaking down organic residues leads to the formation of humus. And in farming, of course, we place a premium on humus, or at least we should. So the question then comes, how long does it take to reach maturity? We should know that in forest systems, it's well known that humification of woody matter takes up to 7 years. That's a pretty long maturity phase. As composters, of course, we try to do it faster by managing the process, but the definition of maturity remains the same. It's the process whereby organic matter is reworked by chemical and biological steps into a relatively stable organic humus. Finally, I would say it might help to make an analogy here to winemaking or cheese making since they involve maturity processes. What I'd like to say is that the result depends on the process, but like any biological process, composting maturation can also go wrong. It can ferment, or it could become odorous, and it can become phytotoxic. Or it can go so far in maturity that many important qualities are lost.
Will, what are some of the ways that we can measure compost maturity?
Well, I guess I can answer that by saying that if we agree that maturity is a process rather than a single attribute, then we can easily see that there may be many ways it can be measured. In the picture here that we're looking at on the screen, which is taken at our research farm, we have set out 3 types of test procedures for maturity testing. The tall blue containers are called Dewar vessels, and they measure self-heating potential in the compost. In the middle, in front of this, you see Solvita test kits, and they measure CO2 respiration rate. And finally, in front or to the side, we have seedling trays with wheat and garden cress that test phytotoxicity. Now, these first 2 tests, that is the Dewar test and the Solvita, are really both measuring respiration rate, which is the rate of decomposition. The Dewar, which is a test from Europe, does it by showing the heat rise, almost like a calorie test. The Solvita, which is a test kit developed by our lab, does it by measuring the amount of CO2 produced. These 2 tests often give similar, but of course not identical results. Finally, the plant tests are measuring maturity in a more complex fashion, since they measure the presence or absence of phytotoxicity, a condition which may also result from incompletely finished composting. There's an important caveat here, too. Maturity does not tell us how much salt or other nutrients a compost may contain, and these have to be measured by other means.
Great. Well, we certainly just talked about laboratory evaluation. Finally, Will, and quickly, I'd like to know, should all compost be completely mature before it is applied?
Well, the crux of this answer is that soils and plants can utilize compost really of varying maturities. And to help understand this, we've constructed a picture that you see on your screen, which is based on the Solvita test process. Based on what I've just said previously, you're probably all thinking that since compost maturity is like cheese making or wine brewing, you must wait to get it completely done. You're thinking, of course, why accept anything half-baked, so to speak? But the information in this chart has been evaluated by many agriculturalists, and I will say we have excellent scientific evidence supporting at least some of it. The chart gives a general picture of how you can use compost at varying stages of maturity for differing end uses based on actual calibration with respiration rates. For example, let me point out that a potting mix must be very mature to result in a good effect. Represented in this table is a purple color 7 or 8 on the scale. But for general garden and topsoil uses, experience does show that compost need not be as mature, or I would say it differently, plant damage is unlikely to result from semi-active compost. I would also add that several states now use this Solvita system and have found for many uses a number 5 or higher on this particular scale is acceptable for general distribution. Anyway, in all this maturity talk, there is a caveat for commercial composters, and that is if you want to get compost out the door quickly to market, and you use a scale like this, you have to consider that the more active a compost is, the more likely you are to have adverse comments if the compost is improperly used. So anyway, from here on out, the rest just falls into place.
Well, thank you very much, Will, for joining us today and shedding light on the issue of compost maturity.
Thank you. It's been a pleasure.
So, now that you have selected the right type of compost for your operation, well, there are still several questions to answer about its use. For example, when should it be applied and how much should be used? Also, will you need to use other inputs or special tillage practices? These are all questions that many compost users face with uncertainty. Obviously, the procedures for using compost will vary depending on the particular farm, crop, soil, and compost product. In the following video, several users describe how they have incorporated compost into their production systems.
When you incorporate compost into your cultural practices, you really need to look at how it benefits everything. And it's not just throwing in one little cog into something that you've already been doing. You may end up changing the way you farm.
Compost is only one part of a system to produce crops better or farm more sustainably. It must fit with other components of the system. One decision growers face is how to allocate compost to crops and fields when the amount of compost is limited.
We'd like to get to where we can apply compost every year to every field, or at least maybe some maintenance every year. We're kind of starting out slow and building a little bit, but our method of operation so far has been to put approximately 10 tons of compost on the year before we grow potatoes in that particular area.
Usually we aim compost at weak areas. Our heavier or better areas, the areas that seem to have high fertility, we then don't go add any more compost to it. Typically we grow cover crop in it and farm it normally.
Timing of compost applications depends on available time, climatic conditions, crop requirements, and the cover cropping practices.
In this particular study, the fall application has been effective, even though the nitrogen mineralization may be reduced, or we may lose some of the nitrogen that's mineralized in the fall. Now, spring application, growers always run into difficult problems of soil compaction because your soils are usually wetter, time is short, and there's not enough time there maybe to incorporate it fully. Now,
I usually try to apply as much as I can in the fall. Occasionally I'll change my mind during the year and do a spring application, but I only do that with certain crops, again, corn or potatoes. I do have concern about the salt levels in compost. It probably is no higher than the salt levels in manure, but the one crop that we grow that is particularly salt sensitive are dry beans, and so we have to be very careful about applying particularly higher levels of compost. And I will always apply compost in the fall, and as I did with manure, if I'm planning to do beans, and then just hope we get some rain. If it's a dry winter, why, we will still have salt problems. But if we get a normal wet as we normally get for winter, we won't have those salt problems.
The winter is the best time for us to grow winter legumes, and if we want to get the maximum nitrogen benefit out of our cover crop, we don't want to be adding a source of nitrogen just before we plant it, because the legume cover crop will take up the available nitrogen in the soil. So we like to apply the compost for our summer crops in the spring and turn them in at the same time that we turn the compost in. Or the cover crop, I mean. So we put the compost, turn the compost and the cover crop in simultaneously.
We've used it in the past as frost protection. We have little strawberry plants over here in our U-pick, and we'll take and lay the compost over the top of the strawberries. After threat of frost has passed, then we just rake it down into the bottom of the furrow, and there it begins to break down and becomes a fertilizer source ultimately for that crop.
Although compost supplies nutrients, it is usually not the sole source of fertility. Conventional farms apply compost to complement rather than replace chemical fertilizers, at least when compost is first used. Organic farmers typically combine compost with cover crops and may add other organic nutrient sources.
We are recommending that they go right on with the cultural practices that they have developed over time, which are successful for them, and then as they see their soil qualities change, they can change their fertilizer application or their pesticide or herbicide applications, but not until they see those things, their agronomist sees those things or their laboratory tells them that they have the opportunity to diminish fertilizer requirements.
Our data shows that a moderate rate of compost applied every year, like 2.5 to 3 tons of compost applied per acre, with a normal fertilization rate gives us the best yield returns as well as economic returns. And this has occurred both on potatoes as well as malting barleys.
You know, we're a conventional farmer. We do add chemical nitrogen, but I think compared with a lot of the farmers in the area, we keep it to a minimum. We do soil testing on our ground, nitrate testing to make sure that we're not over fertilizing, and we try and keep our nitrogen level input to a minimum for growing the crop.
The cover crop and the compost is really our main fertility, but there's several other materials that we've been using the last couple years to supplement. A crop like peppers really requires a lot of nitrogen and is a heavy user of nitrogen. So on top of the 10 tons of compost, a lot of times we will pre-plant feather meal, and then we also will occasionally side dress with seabird guano. And then these peppers are irrigated through drip irrigation, and we've used a couple liquid materials that can be applied in drip irrigation systems.
Growers are also aware that tillage practices can influence the effectiveness of compost.
As far as tillage of compost after I applied it, I've done a lot of things. This year I'm trying something I'm leaving on top of the ground. I realize I'm going to have some trouble with killing off some of the microorganisms that are in it, but I've already planted some cover crops, so I've just kind of top dressed it. And we're getting rains too, so we're getting some of that into it. But normally when I apply it in the fall, I just usually disc it, and then I will go ahead and chisel plow. So some of it gets worked in relatively deep, and a lot of it stays on the surface. As I said earlier, I never use a moldboard plow, and I think that would be a waste of the material to put it on and plow it down. I mean, it'd be down there where it wouldn't do any good at all.
We do all our composting conventionally after fumigation. So we're putting the good microbes back in the ground. So once a field is fumigated, it's land planed, and then the compost is spread on. We'll spend approximately a month and a half preparing the land, disking it down, getting it as fine as we can, deep ripping, opening up the soil to air out. So we're usually applying compost towards the middle to end of September, and then right after that we're making our beds. We'll do that right after the compost. So the compost is folded into the bed. If we put the compost on at the start of the process, we'd be driving it down. So our goal is to have the compost in the bed.
There appears to be great variation with regard to compost application rates. Some users report using 1.5 tons per acre, while others say they use more than 25 tons per acre. Dan Sullivan will now give a short presentation about how to determine appropriate compost application rates. Dan?
Okay, well, through the wonders of modern technology, I'm about to get on my computer here and show you a slideshow. So pretend you're at the slide. Here comes slide number 1. Basically, when you're looking at different compost application rates, the first thing to think about is what are your goals? I'm going to kind of review some of the goals that have been presented today in the show. Some are interested in improving the soil health or microbial life in the soil. You may be interested more in nutrients, different nutrients for different folks, nitrogen, phosphorus, potassium, micronutrients. Your goal may be simply to increase organic matter. Some growers have kind of a reclamation program going on where they're trying to increase the productivity of certain pieces of their cropland. Others use compost for mulch, and when you use a mulch application, this is probably the highest application rate. These uses here are roughly grouped from low rates to high rates. Looking at some things that limit application rates, of course there's the return on investment or the economics, what spreading equipment you have available, and this is usually a limitation on the low end of application rates. Often rates lower than 3 tons per acre are tough to put out with some equipment. For different cropping systems, you're going to have different windows for application. There are some compost characteristics which, if you apply too much compost, can cause problems. Some of these have been mentioned earlier. High salts. Some composts will have a very high pH due to the addition of things like ash. And some composts will have high concentrations of ammonium nitrogen, which can result in toxicity as well. Another consideration that I'm going to spend a little bit of time with is how much nitrogen does your crop need, and how does compost figure into your nitrogen application program? It's important to understand that in compost you have different forms of nitrogen. Mainly you have organic nitrogen, and the rate of release of that organic nitrogen to forms that plants use depends on compost stability and compost carbon to nitrogen ratio. This graph here shows different compost samples collected from compost production facilities in Western Washington, Western Oregon. Each dot is a different sample. And what you see is that compost total nitrogen contents can range from about 0.5% up to 3%. When you get compost that has greater than 1.5% nitrogen on a total basis, you're pretty well assured that mineralization will occur, because generally those composts have carbon-nitrogen ratios that are less than 20:1. When you get below 1.5% nitrogen, then you have a wide range in carbon-nitrogen ratios, and so it's harder to predict. So let's look at a scenario for kind of a medium application rate and how much available nitrogen we expect to be released. I've divided the world up into 3 composts, realizing that this is unrealistic, but for illustration purposes, I've called them a manure compost, which is an example of a high nitrogen compost, which also has a high availability of nitrogen during the first year. In contrast to that is a low nitrogen compost. Yard waste compost or yard trimmings composts are typically in this kind of a range for nitrogen analysis. Mature compost can have high or low nitrogen analyses, but I've picked 2% for my example here. So at the 5-ton rate, we're looking at availability between 0 and 75 pounds of available nitrogen per acre per year. So what happens over the long term as we apply this 5-ton application rate to the same field for a period of years? Well, we know that what's going to happen is that the organic nitrogen will gradually break down to available forms, nitrate and ammonium. And research has shown that about 10% of the nitrogen that's remaining after the first year breaks down in each succeeding year. So if we go back to our example, we mineralize 50% of the manure compost, so we have approximately 50% left at the start of year 2. The other compost didn't decompose as much, so we have more nitrogen that is stored in organic forms in the soil. So if we look at our bank account, we've got between 50 to 90 pounds of nitrogen stored in the soil per acre. We're going to apply this amount of new available nitrogen with our 5-ton rate. We add our interest from the past, so to speak, and so our availability after 5 years of 5 tons per acre is something between 20 to 100 pounds of available nitrogen per acre, depending on compost quality and compost analysis. So in summary, Compost alone usually won't supply enough nitrogen for crop production. Repeated compost applications build up a reserve of slowly available nitrogen. And the usual strategy is to reduce nitrogen inputs from other sources over time when you're applying compost. And that wraps up the nitrogen portion of the compost application rate primer.
Great, thank you very much, Dan. Well, now it's time to address your questions. We certainly appreciate your submitting them. Well, we do have many questions here, and it's unlikely that we'll get to all of them, and more are coming in as I speak. So those that we do not answer here today, we will post on our website with an answer from an appropriate expert. So keep sending in the questions. Okay, our first question comes from our site in Ventura, California, and the question is, I will direct this one to Mark Buchanan. What advantage is there to using compost versus cover cropping?
Well, you know, I think that's a very important question, and it really comes back to what are the specific end user objectives, what are the grower objectives. Cover cropping is a very effective way, particularly in our region, to improve soil structure quite rapidly. And a number of conventional growers have found that reintroducing cover cropping back into their system is actually reducing their diesel fuel bill in terms of primary tillage, secondary tillage requirements. Cover cropping is well in terms of using legumes, essentially is bringing in and utilizing atmospheric nitrogen and bringing in nitrogen to the soil system also, which are our net pluses. Composting can, under many circumstances, provide, however, a more stable form of organic matter, a more resistant to decomposition form of organic matter. And some studies I've done, not necessarily in California, but out in the southeastern United States, we found with cover cropping and turning it in for nitrogen management, turning in a legume early for nitrogen management, we actually decrease soil organic matter by essentially kind of getting everybody stimulated in the ground, and there was actually a decrease in organic matter. Whereas when we were putting or reintroducing a more stabilized or more woody or lignified material back into the ground, we'd see either a maintenance of that organic matter level or an increase. So that's a little bit of it. It's a fairly large question, so I'll try to keep it brief.
Okay, great, thank you. This question is from Portland, Oregon. I'll direct it to John Paul. It's talking about salt problems. Can you elaborate on the salt problem? What compost materials pose the most problems and what have the least?
Well, the salt problem is it's an interesting one. Salts refer to all of the soluble nutrients in composted material. Typically, and it largely depends on where the compost is being produced. In the western states where we get a lot of rainfall, if you're composting outside, you're going to be washing away a lot of these soluble nutrients, and which will result in lower salt concentrations. If you compost indoors, you will typically increase your salt concentrations as the compost matures because you're concentrating the material. Salt causes a problem in the soil largely because it robs the soil, or it robs the plant of the water that's in the plant, and therefore really dehydrates the plant.
So it's as much a factor of geography and location as it is of the compost?
It's a factor of geography, location, the type of material that we're starting off with, like an animal manure, such as a poultry manure is very high salt concentration to begin with. It's a factor of, are you composting indoors or outdoors, and what are you mixing it with? If it's a low salt concentration bulking agent, such as wood, you can lower your salt concentrations. But by and large, there are a lot of factors. Salt is really important, and it needs to be measured.
Okay, thank you. Here's a question from our site in Ventura, California. I'll direct this one to Marcy. Is there any benefit to adding inoculants to compost?
Well, Eric, it depends upon what particular inoculants you're referring to. If you're thinking about beneficial microorganisms for disease control, it's not very practical. It's theoretically possible. But you have to consider that in order to get specific microorganisms to colonize your compost in significant populations, you have to add them at a fairly hot, while the compost is still fairly hot, so that the compost hasn't been recolonized by other microbes. If you take a mature or end product compost, a cooled compost, and you inoculate it, there's going to be very little effect. And it's extremely difficult to inoculate at the right time without having other contaminants or organisms have the same opportunity as your beneficials. Any inoculants added before the high temperature phase of composting would be killed during the high temperature phase.
Okay. This question comes from a site in Wenatchee, Washington. Is anyone looking at contaminants in compost? I'll direct this to you, Dan Sullivan. In particular, are heavy metals, dioxins in compost from wood or paper byproducts, are these of real concern?
Generally, there's been a lot of interest over the last year in metals in all kinds of fertilizers, byproducts, composts, you name it. This is becoming more of an issue. As far as, should we worry about this issue? Generally speaking, if you know your feedstocks and you know that those feedstocks originate from the farm, I wouldn't be very worried about heavy metals in compost. If you're including some industrial byproducts or byproducts that come from someone else and you want to look at those and test those for heavy metals, that would be a prudent thing to do. As far as in Europe, there's been quite a bit of work prior to last year with metals and composts, and they found that you get the lowest metal concentrations by source separating things like produce waste from other components of, if you're doing composting of mixed materials from refuse pickup. The cleanest compost comes from source separated materials. So know your materials, analyze them if they're questionable, and also, as Bob Miller mentioned earlier in the broadcast, there are labs that can do heavy metals in compost.
Great. This question comes to us from Bellingham, Washington, and they're asking, what is the difference in using compost leachate versus using compost tea? Mark, would you like to try to address that?
In some cases, compost tea and compost leachate may be identical. It really, and in the area of compost teas in general, there's again a lot of inconsistency because the approach to defining what a compost tea is quite different. So in some cases, I just did a project where essentially we could call compost tea a compost leachate because we were using a very passive and short-term extraction system. In another case, we were defining compost tea by a highly aerobic system, which we added a sugar source to stimulate microbial growth in it. So the whole area of compost tea versus leachate is, again, we've got this problem of defining. However, one of the important things that you would get out of any of these leachates is, number one, you are getting a wide variety of microbial functional groups, which you are either in terms of applying to foliage or applying to soil. There's, in some cases, a net benefit there, potentially in terms of competition with other pathogens in some cases. Inevitably, we are extracting nutrients, and so from the perspective of additional nutrition to a plant by applying this on a foliar basis, we can certainly look at it from a nutrient point of view. And then also, inevitably in that leachate, we have a lot of low molecular weight humic compounds and a lot of other potential biostimulants that may be in that brew.
Okay, thank you. Our next question comes to us from one of our local sites, Moscow, Idaho. And the question is, why did the farmers in some of the videos report different levels of organic matter increase? And there was a variety of results that they talked about. I guess I'll throw this one to you, John. We heard a number of different percentages of increase in organic matter. What's your read on that?
Well, it's very difficult to predict how much your organic matter will increase with compost addition. It depends on a lot of factors. It depends on the maturity of the compost. It depends on the climatic conditions, how fast will the organic matter oxidize under these in any particular climate. For example, in British Columbia, in one study, we took the organic matter from 1.9% up to 3.8% in 4 years by adding 20 tons of compost per acre. Now, if you do the math, there's really almost a 50 to 75% reduction over those 4 years in the organic matter that we added. So we are adding even though compost is stable, when we add it to soil, it does oxidize and continue to decompose. And so it's highly dependent on the compost. It's also the climate and the cropping regime.
Thank you. We have a question here from Santa Clara, California. I think I will direct this one to Marcy. It's talking about what is the fate of antibiotics, vitamins, and other feed supplements regarding animal waste compost? Can these products be detected by lab tests? Any ideas of how those might carry over?
I haven't spent a lot of time really looking at this specific issue, but antibiotics, being a biologically produced substance, tend to be microbially degraded during the composting process. So, and I would think vitamins and other nutrients would just be part of the food web. Maybe if anybody else has any comments on this.
So your assumption would be that they would be degraded just along with the other.
However, that assumes a thorough thermophilic composting process, and we always need to emphasize that we are assuming a thorough composting and thermophilic phase during that.
Okay. I guess it gets to the point of knowing the source of your compost and knowing the quality that it exists in. Okay. I have another question from our site in Moscow. Can compost, I'll direct this to Dan, can compost made from biosolids be used for agricultural crops?
Yes, composted biosolids are approved for land application. They don't require a permit if they meet the EPA Class A requirements, which there's process requirements you have to meet to produce Class A compost. Essentially what you're dealing with Class A biosolids compost is that compost is essentially pathogen-free.
Okay. Have another question from Wenatchee, Washington. Direct this to Mark because he commented earlier about zinc nutrients. What is the type of compost that can improve zinc levels in soil?
Well, again, that's a fairly large question, and we're dealing with a very heterogeneous material and heterogeneous world. However, first thing, obviously, you've got to have some sources of zinc. That's the first thing. However, one of the important things that does go on during the composting process is that a number of the microelements tend to get locked up in chelated form. So we're assuming, and I should add a caveat to the observations that I've been involved in. Again, they're involved with vegetable crops, and in many cases where we are adding the compost into the planting bed as opposed to broadcasting it generally over a flat field. So we're actually incorporating and concentrating that element there. And I am assuming from our data that we're just looking at perhaps the improvement from this addition of chelated zinc, which again is highly mobile to the plant root surface and easily taken up as well.
You wanted to follow up on that, Dan?
Yeah, one of the effects you can have with compost is that typically compost will reduce the pH in soils that are high in pH and have a problem with zinc availability. So that wouldn't necessarily be the zinc that's in the compost, but just the zinc improving the conditions in the soil for zinc to become plant available.
Okay, well, thank you. Well, unfortunately, we've run out of time for this part, for our question and answer. I certainly want to thank our panelists. Thank you for sending them in. We're sorry we could not address all of the questions, but we will list the questions and the answers on our website, and I'll again give you that website address. It is www.aste.usu.edu/compost. And I would also mention we have answers to the questions from our first program on that site as well. Now we'd like to take a few moments to mention some of the other products that are available through the SURWA project. We have a third satellite workshop in the series that will look more closely at the trends and emerging issues related to composting and compost use in agriculture. That workshop is scheduled for next fall. We will notify all site facilitators when the date is set. In the meantime, you can check the website for details. Now, the workshops are only one component of SURWA. We are developing other methods to help you learn more about compost. For example, we have a quarterly newsletter. We're also developing slide sets and a college-level internet course about composting and compost use. In addition, we have some funding available that can be used to support local tours. If you are interested in these educational materials or opportunities, please contact us or consult our website for more information. Now, JG Press, who is the publisher of BioCycle magazine, has generously donated 6 awards to us, to the project, for us to raffle to our dedicated site facilitators. The awards are 2 subscriptions to BioCycle, 2 subscriptions to the Journal of Compost Science and Utilization, and 2 complimentary registrations to a BioCycle conference. There are 2 upcoming conferences in the Western region this spring: the West Coast Conference in San Francisco this March, and the BioCycle National Conference in Albuquerque, New Mexico in May. And now the award winners are, whose names were drawn randomly, are Ben Faber from Ventura, California, Claire Klock from Portland, Oregon, Woody Winans from Parker, Arizona, Jim Schmollinger from Caldwell, Idaho, Joan Proctor from Eugene, Oregon, and Doug Cohn from Logan, Utah. We'd certainly like to thank JG Press for their generosity and support of the project, and congratulations to our prize winners. While we have many other thank yous to give to the many people that have helped make this broadcast happen, I'd like to begin by thanking our panel of experts here in the studio: Dan Sullivan, John Paul, Mark Buchanan, and Marcy Grebus. Thank you for taking the time to come and be with us today. Thank you also to our experts who joined us by telephone: Arnold King, Ralph Juergens, Bob Miller, and Will Brinton. We certainly appreciate the assistance, knowledge, and experiences that the many farmers and researchers shared with us in the videotape segments that we've been showing you. I'd also like to thank the SURWA project team and all of the contributing technical professionals and our project partners, including the SARE program, who have helped to make this project possible. We also want to recognize our local site facilitators, the folks at each of your local receive sites who have done so much of the legwork and the coordination to create a local program for you. And finally, we would like to thank you for attending today's workshop. We hope that you will join us for our next workshop and that you will make use of the other SURWA educational materials. Thank you and good day.